if you and I think of this eigenvector, sorry guys, can I go back and relabel again? Jeepers. I call it lambda 1. Therefore, V1 bar as a vector, Michael, has entries V1, V2, and V3. And what that second row really tells me is that 1 times V3 is equal to 0, which tells me V3 is equal to 0. How many free variables? How many free variables?
3.
How many free variables here?
2.
How many?
None. I don't know. C1 is C2.
No, you'd have one.
So you only have one free variable.
One free
Yes,
variable.
you'd have one.
Because if I allow V2 to be T, V1 is going to be T.
Yep.
So I think a corresponding eigenvector V1 bar could be interpreted as this column vector. How about
1, 1, 0.
very nice. I agree completely. Well, to dive in and find the corresponding eigenvector or vectors to lambda 2 be equal to 5. Thank you. Excuse me. Taking that matrix A. Subtracting 5. Excuse me. Down the main diagonal. Does it give me the following? Is that a negative 2? Negative 2, 0, 0. Oh, same thing. Negative 2, negative 2, 0, 0. And then 0, 0, 0, 0. Or shall I say in reduction? Gosh, this is so fast, isn't it? Well, maybe not that fast. Let's see how fast you guys are. How many free variables?
1.
I can't hear you.
2.
2. Did you guys see it? Because I think what this equation says is the following.
Oh,
If
yes.
V2 bar is equal to
Because one's going to be a negative of the other, so you
V4, V5, V6, I think what the first row says,
and one can be anything.
I think what the first row says is that V4 minus or plus V5 is equal to 0, which necessarily implies that V4 and V5 have opposite signs. And it also says that V6 is equal to down there.
Anything.
Thank you. V6, or maybe call it T or K or whatever you want. That being the case, I think one corresponding eigenvector V2 bar is going to be nothing more than how about 1, negative 1? 0. And I think a V3 bar will be nothing more than 0, 0, 1. So I think in the end, I can see that the second solution, gosh, I never even stayed with them, didn't I? Jeepers. You guys over here with the first eigenvalue, what would x1 bar t be? How do I write that?
What is that you've just written?
X1 bar t.
Oh, I'm trying to look at it upside down. This is, all right, I see it
Yeah,
now.
rotate the other way.
Okay, I thought that was some of Alex's alien writing.
Oh, come on, you guys. 1, 1, 0. E to the t. But over here, I think x2 bar of t
There we go.
is going to be expressed as
0, 0, 1.
oh, that one over there. Sorry. Yes.
E to the 5.
But x of 3 bar t is going to be times. So, in the end,
When do we solve for E?
what was that?
E 3 bar?
What did we solve for e?
X3 bar of T. Where did you get that?
Well, these are two completely different eigenvectors
Oh.
corresponding to eigenvalue there. And so I think it generates 2 more solutions. Thank goodness. Because I wanted 3 eigenvectors for the 3 by 3 matrix A so that my matrix A is not going to be defective. A is a non-defective matrix.
You created 2 eigenvectors for 1 eigenvalue.
You make me so powerful, sound so powerful. How do you create them? I just did math.
Just checking on eigenvectors. When you have a variable allowed to range over anything like V6,
Yes.
its corresponding eigenvector is just going to be 0 everywhere except for...
Yes. Yeah, I agree. So I think all my solutions, my x bar t, are going to be linear combinations of these 3. That would be a C1, 1, 1, 0. E to the
T.
thank you, t. plus my C2 times 0, 0, 1 times my e to the 5t plus my C3 times my 1, negative 1, 0, and yet again another e to the 5t.
Why did you put a bar over your O in the word so?
I'm sorry, it's even skills development 582, 581. Sorry. So you guys ready to show me you know your stuff?
Yeah.
But it is